You are listening to the HYDAC podcast. In each episode, we share our knowledge with you in topics related to hydraulics and automation and control, from the basics to the current trends. Stay tuned. Welcome to this episode of HYDAC podcast. I'm your host, William Shaw, and on this episode, where we are discussing the fundamentals of hydraulic pumps, along with some basic pump controllers. Here in the studio to discuss this topic, I have Mr. Raj Singh. Raj is a maths and physics graduate and has been involved in the fluid power industry for over 15 years. He works for HYDAC as the National Development Manager for Mobile Control Systems. A key component of his role is designing innovative solutions and systems for mobile applications. Welcome, Raj, and thank you for joining us on this episode of HYDAC podcast. Firstly, what is a hydraulic pump?
Thanks for the kind introduction, William. Basically, a hydraulic pump converts mechanical energy into hydraulic energy. When a hydraulic pump operates, it performs two functions. First, its mechanical action creates a vacuum at the pump inlet, which allows atmospheric pressure to push the liquid from the tank into the inlet line of the pump. Secondly, its mechanical action delivers this liquid to the pump outlet and discharges it into the hydraulic system, which is hydraulic flow.
So if the pump is relying on atmospheric pressure to push the fluid into the suction side of the pump, is there a limit on how long the suction hose can be?
Yes, depending on the vacuum the pump can create, there is a maximum length, but even with a perfect vacuum, there is a finite length. Also, an important consideration for the suction side of the pump is to minimize the fittings which create restrictions on the suction side.
So what is hydraulic flow and how is that calculated?
It is defined as the volume of a substance that flows through a defined surface area over a specified period of time. The formula for flow, Q liters per minute, is equal to the displacement of the pump, cc's per revolution, multiplied by the input speed, which is in RPM, revolutions per minute, multiplied by the volumetric efficiency of the pump, divided by a constant, which is 1,000.
So I've also heard the term pressure being used for a hydraulic system. What is this and how do you calculate the pressure?
Pressure is resistance to flow and measured in bar. The formula P in bar is equal to force, which is measured in Newton, divided by the area, which is in centimeters per squared, times a constant 10. You always have to be very careful of the SI units when applying these formulas to ensure that you get the right answer.
I've also heard of other units of pressure being used, such as PSI and pascals. Is this different from bar, and how so?
The pressure can also be measured in PSI, which is imperial, and generally in Australia we use metric, and that is bar. So 1 bar is equal to 10 to the power 5, or 1 megapascal is equal to 10 bar.
So just coming back to the topic of this podcast, of hydraulic pumps, what are the different types of hydraulic pumps?
Hydraulic pumps can be classified into two groups. Fixed displacement. Displacement cannot be varied. Some examples are gear pumps, screw pumps, vane pumps, and bent axis piston pumps, with gear pump being the most simplest and most commonly used as they are easily maintained and cost effective. Good for constant flow and constant pressure applications, typically less expensive than the variable pump. The next one is variable displacement. Displacement of the pump can be varied while the shaft speed remains constant. This is achieved with integrated controllers. Some examples are axial piston pumps, bent axis piston pumps, radial piston pumps, and etc. This is good for variable flow and or pressure applications, typically more energy efficient because flow and pressure, that is equal to horsepower, matches more closely with the load.
So how does the displacement change in variable displacement pumps?
There are various methods of upstroking and destroking the pump, which alters the displacement of the pump. This will be discussed in the next podcast, which will be on pump controllers.
Would you be able to give some examples of basic pump controllers that you find on a variable displacement pump?
Sure. One of the most common one is the pressure compensator. The pressure compensator maintains a constant system pressure in the hydraulic circuit by varying the output flow of the pump. It's always in the high pressure standby mode when flow is not required. The high standby pressure mode is equal to the PC setting. Some typical applications, you can use it on a constant 4 cylinders, balers, compactors, refuse trucks, or on-off vane drives or sweepers. The next one, which is also quite commonly used, is the remote pressure compensator. The remote pressure compensator is a 2-stage control that allows multiple PC settings. The remote PC control uses a pilot line connected to an external relief valve. It can be direct acting or proportional pressure relief valve coupled with a microcontroller. The controller looks similar to a load sense controller, however with an additional gallery connecting the external relief valve to the remote pressure cutoff spool, then to the pressure limiting spool, and then to the pump outlet. Some typical applications: modulating fan drives, combine harvesters or wood chippers, and many more. And the third one, that is one of the most commonly used one in the market, the load sense control. The load sense control matches system requirements for both pressure and flow in a circuit regardless of the working pressure. Low standby pressure when flow is not required. Some typical applications, it can be on drill rigs, hydro excavators, high pressure water pump drive systems, or refuse trucks. Or we can say any load sensing system will be a vast improvement in energy savings and temperature over a pressure component system or fixed displacement systems.
Thanks, Raj, for running us through them. Before we let you go, what are some of the most basic misconceptions in the hydraulic industry?
People believe that the pump produces pressure, which is incorrect. It produces flow, and the resistance to flow is pressure. While it's common for people to think of a pump's inlet as sucking in oil, in reality it is atmospheric pressure doing the work. In essence, the weight of the atmosphere pushes the oil out of the reservoir and into the region of lower pressure, the inlet. Once the oil is forced from the reservoir and through the inlet, it then moves the volume of liquid into a region of decreasing volume to create flow.
Thanks, Raj, and thank you everyone for listening.
Thank you. Thanks, William.
Stay tuned for our next episode of HYDAC Podcast, which will be coming soon. Thanks for joining us on this episode of HYDAC Podcast. For an in-depth learning on the subject you've just listened to, enrol on the technical training at HYDAC Australia. For more information, visit our website, hydac.com.au. HYDAC, global presence, local competence.